related to change in
Actually,
temperature.
yes.
It's
Please.
related to change in temperature. So by changing the temperature, what properties you are going to measure?
Sir, evolution of any gas.
Evolution of gas, how will you measure that?
Sir, we can observe that, we cannot measure that.
So that will be difficult, that you have to use some other instrument to measure what type of gas is evolved,
Yes,
right?
sir.
Yeah. So how temperature, or how from thermal analysis we are going to analyze a particular sample? Suppose I am saying that you have been provided with a sample, a solid sample. For example, I am saying you have been provided with calcium carbonate chalk powder. Okay. And I am saying that, okay, you have to go for thermal analysis. Then first you have to know what is thermal analysis, how it is done, what are the different methods that are being used for thermal analysis, right? So when we are talking about thermal analysis, so when we are talking about thermal analysis, it is a branch of material science where the properties of material are studied as they changes with temperature, right? So thermal study or thermal analysis is a branch of material science where the property of material are studied as they change with temperature. And several methods are commonly used, and these are distinguished from one another by the property which is measured. So I have taken example. For example, you have been provided with a chalk powder, that is calcium carbonate, right? And I am saying that thermal analysis should be done for that material. So you are providing some heat to that particular material. Now what will happen? What will happen to the material? Yes, anyone?
सर अगर सॉलिड
कलर
मटेरियल होगा
चेंज।
एक्सपैंड कर जाएगा।
कलर चेंज तो होगा, ठीक है, लेकिन क्या होगा, प्रोसेस हो सकता है। यस।
So can you please repeat the question?
My question is, suppose I have given you a sample, right? For example, calcium carbonate or a chalk that is calcium carbonate. I have given you calcium carbonate. I am saying that you have to do thermal analysis and you are going to heat that particular chalk. What will happen to that particular sample, right? What will happen when you are providing
So,
heat to the sample?
it will decompose and CO2 gas will be released, which can be tested with the help of alky by passing it through lime water.
Okay, we are
सर
not going to analyze. And
अगर
first
चौक
thing,
जलाने पर अगर चौक जलाने पर काली होगी मतलब उसके अंदर कार्बन है।
नहीं वो तो कार्बन है, ठीक है, लेकिन क्या होगा, फर्स्ट देयर विल बी इवापोरेशन ऑफ वाटर मॉलिक्यूल एट 100 डिग्री सेंटीग्रेड, है ना? इट मींस द सैंपल विल स्टार्ट डिकम्पोजिंग एट when we are giving a temperature, right? We will study that, that's not a problem. So all the basis of thermal analysis, there are different methods that are being used in thermal analysis, or we can say that for thermal analysis different methods are being proposed that we will study one by one. So thermal analysis is defined as series of techniques for measuring the temperature dependency of a physical property of a certain substance while varying the temperature of the substance according to a specific program. And the substance referred to here include reaction product, right? So it can be used for measuring the physical properties, including the mass, temperature, enthalpy, dimension, dynamic characteristics, and other. And depending on the physical property to be measured, the techniques of thermal analysis are differential thermal analysis, differential scanning calorimetry, and thermogravimetric analysis. Some other techniques are also there, but in syllabus you have to study only these three techniques. That is differential thermal analysis, that is abbreviated as DTA, in which you measure the temperature difference; differential scanning calorimetry, in which you measure the enthalpy, also abbreviated as DSC; and thermogravimetric analysis, also known as TGA, where you measure the mass of the sample. So these are the techniques that you have to study. Now, differential scanning calorimetry, that is DSC, the heat absorbed or liberated during heating or cooling is measured. In TGA, It measures the change in the weight during heating or cooling. And DTA measures, they are usually for the thermal investigation, where thermal change can be observed and characterized. So one by one, we will go through all these three techniques. We will discuss about the principle involves, then instrumentation, then the curves that is associated with this technique, and then we will go for the applications of this technique. So first we will start with TGA, that is thermogravimetric analysis. Now, thermogravimetric analysis is the most widely used thermal method, and it is based on the measurement of mass loss of material as a function of temperature. It means if you are giving a heat to a material, what is the change in the mass of the material? It is measured using thermogravimetric analysis or measured using TGA. So in TGA, a continuous graph of mass change against the temperature is obtained when a substance is heated at a uniform rate or kept at a constant temperature. And the plot of mass change versus temperature is referred to as the thermogravimetric curve, that is known as a TG curve. So in TG curve, yes, what you see when you are giving, you just on the right side of the screen, you will see that this is a graph, typical graph for TG curve, and you will see that when you are increasing the temperature linearly, there is change in the mass of the system. You will see that up to the point Ti, there is no change in the mass of system. That is a straight line. After that, there is a decrease in the mass of the system. So you study how much of the mass is being decreased. That is studied using TGA, that is thermogravimetric analysis. So in the TG curve, we generally plot mass M, that is decreasing downward on the y-axis, and temperature T, that is increasing right on the x-axis. Just you can see on the right side of the curve, right? Right side of this slide, right? So in TGA, we generally analyze the change in mass of the system with increase in temperature. Clear to all of you? Yes?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Done. Okay, so that is the basic principle in thermogravimetric analysis. Now coming to the instrumentation of TGA. What is the basic instrumentation of TGA? So on a screen you can see that the TGA consists of a sample holder with environment control equipment where the sample is being kept, which is thermally insulated, that is thermally insulated, and it is connected with a furnace that is connected with a microprocessor controlled power source, right? Now this sample is connected with an analytical thermobalance and a temperature sensor, and a recorder measures the change in mass of the sample with respect to change in the temperature. So when you are coming to the instrumentation of TGA, it mainly consists of a furnace, right? A furnace, a sample holder with environment control equipment, an analytical thermobalance, and a recorder. So what happens in the instrumentation? If you are going discussing the instrument, what will happen? Now, the basic requirement is the sample should be thermally insulated and it is kept in an environmental control equipment. So why there is a need for an environment control equipment? Yes, anyone? Why there is a need for environment control equipment?
so that the
Sir, because
temperature
it
remains
is,
constant.
Huh? So that
So temperature remains constant.
the temperature constant के लिए thermal insulation दे दिया, right? So it will thermal insulation is there. It means the sample will not react or not. There will be low effect of outer atmosphere all the sample, right? Or the outer temperature all the sample. Now, why there is a need for environment control equipments, or
sir,
why
to
it is?
provide certain conditions so that the process can take place.
Generally the sample is placed in such a chamber that is inert, right? So that it does not react with the atmospheric condition, right? अगर एटमॉस्फेयर से रिएक्ट किया होगा तो ऑक्सीडाइज हो सकता है ना? तो फिर आपके सैंपल्स में एरर आ सकती है, बाहर से वो मॉइस्चर एब्जॉर्ब कर सकता है. सो इट इज कीप टिल कंडीशन that it does not react with the outer atmosphere. So it is keep tight in a sample holder that is environmentally control equipment, and it is environment controlled by blowing nitrogen gas into the system. आप नाइट्रोजन गैस इसमें ब्लो करते हैं जिससे वो क्या होता है, इनर्ट रहता है, तो ऑक्सीजन से रिएक्ट नहीं करेगा. क्लियर? क्लियर एवरीवन?
Yes, sir.
Yes, sir.
Yes.
Yes.
Now this sample holder is connected with a furnace which provide a constant heating rate, and this constant heating rate is provided by the microprocessor controlled power source. And this constant heating rate, this microprocessor control power source provide a constant heating rate at the rate of 10 degrees centigrade per minute to 20 degrees centigrade per minute, that you can vary. For example, I am saying that the temperature is increased from 40 degrees centigrade to 1200 centigrade. So for generally for a TGA, if you want to do a TGA, the range is from 40 degrees centigrade to 900 degrees centigrade, or in some advanced instrument you can measure up to minus 150 degrees centigrade to 2000 degrees centigrade. So if you are increasing the temperature from 40 degrees centigrade and if you are going to 900 degrees centigrade, this microprocessor control source control the linear increase in the temperature. So the temperature will increase linearly from, for example, I'm saying you have maintained a linear temperature of 10 degrees centigrade per minute. So the temperature will increase at the rate of 10 degrees centigrade per minute. It means if you are starting from 40, it will be after 1 minute it will be 50, after second minute it will be 60, 70, 80, 90. If you have put a value of 20 degrees centigrade per minute, the temperature will be from 40, 60, then 80, then 100 after per 2 minutes. So this microprocessor control power source provide a linear increase in the temperature to the sample. Clear to all of you? Yes?
Yes, sir.
Yes, sir.
Yes. Now, when you are providing a constant temperature to the sample, well, you are providing a linear increase in the temperature, and what will happen, the sample will start decomposing, or there must be some change in the mass of the system, and that is measured by the analytical thermobalance. This analytical thermobalance measures the change in the mass of the sample with respect to the temperature, and that is plotted by the recorder. That is the basic instrumentation for the TGA. So while I am saying that the bell and the what are the main components of a TGA, that is thermobalance, then it consists of a furnace, right, a sample holder which is environmental control and thermally insulated, a furnace that is controlled by a microprocessor control power source, a temperature sensor, analytical thermobalance, and a recorder. So it consists of a balance, furnace, heating device, unit for temperature measurement and control, recorder that automatic record the unit for the mass and temperature change. So the balance is the basic requirement of automatic recording balance and will include accuracy, sensitivity, reproducibility, and capacity. Furnace we have already discussed. Yes. Now, based on the TGA analysis, you will obtain a curve like this. So if you are analyzing a sample, this is a typical curve for a TGA analysis, that is TG curve for a particular sample. So on this, you will see that on the x-axis, that is a temperature, that is a linear increase in the temperature, and y-axis, that is the mass, that is in gram. Okay, the screen is visible to all of you.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes.
Yes,
So
sir.
now on the
Yes, sir.
curve, you will see that there are two regions. That is a straight region, right? That is the horizontal region. This one, I. This is the first region. I not. This is the first region. Region first. That is a horizontal region, and this is the region second. That is a slanting downward portion of the curve. That is region second. So in a TGA curve, there are generally two regions. That is the horizontal region, and there is a second slanting downward portion. So what this horizontal portion represents? Yes, anyone? What this horizontal portion represents?
So the mass before the reaction.
Not before the reaction, during the reaction. It shows the temperature आपका increase हो रहा है ना यहाँ से यहाँ तक, तो it shows the stability of the material up to that temperature, right? You will see that that is a straight line. It means the material is stable up to this temperature, right? So well, I was saying that the horizontal portion, that is the region 1, indicates the region where there is no mass change, or there is no change in the mass with increase in the temperature. And from this, we can know about the thermal stability of the material. We can know that up to that temperature, the material is stable. And this information is very important to the engineer because it reveals the temperature range in which substance like polymer, packing material, alloys, and building material may be safely used. Suppose you want to know about the stability of the polymer, right? Then what you will do, you will put it for a TG analysis, and you will see that after that, after certain temperature, for example, I am saying that after 50 degrees centigrade, it will start melting. So you can see that after 50 degrees, there will be a downfall in the curve. So you can say that the material is up to stable up to 50 degrees centigrade. Clear, everyone?
Yes, sir.
Yes, sir.
Now, the
Yes,
second
sir.
region, that is the slanting downward portion, indicate the region which represent the wet loss. And this wet loss is due to dehydration, rupture, formation of volatile product due to decomposition or dissociation. So this explains the wet loss, and the wet loss may be due to decomposition, dehydration, or the rupture of the samples, right? So this is the result second in the TGA curve. So the TGA curve is clear to all of you. It mainly consists of two portions. That is a horizontal portion, and second is the slanting downward portion. The horizontal portion represents the stability of the material, where the slanting downward portion represents the wet loss of the material with increase in the temperature. Clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Okay. That this is a typical curve. This is a normal curve for TGA. And when you are doing a TGA analysis, there is probability that you can get many more type of curve. Now, how to interpret these curves? Why are these curves good, or are the obtained curve is right for your analysis or not? Let's see different curves that are being obtained using the TGA analysis, right? So on your screen, you will see that there is 7 curves that have been shown in the screen, right? The screen is visible to all of you.
Yes, sir.
Yes, sir.
Yes, sir.
So let's see, on the x-axis, that is the temperature, and the y-axis is the mass, right? So let's study for the curve first, right? Curve first. It's so a straight line. So what does it mean?
No mass change
Sir,
with
no mass.
increasing
It means
temperature.
there is no mass change with increase in the temperature. Clear? So we are going up to a higher temperature. For example, we are going from 40 degrees centigrade to 900 degrees centigrade, and there is no change in the mass of the system. It means you can see that the material is stable up to that particular specific temperature. Clear?
Yes, sir.
So the
Yes.
temperature undergoes no decomposition with loss of volatile product over the temperature range. So, but solid phase transformation, melting, etc. cannot be detected by the TG. So you cannot detect anything from this curve. Right. Now curve second. What does it mean? It, you will see that there is a slight decrease in the curve, and after that it's going stable. It means there is a rapid initial mass loss that is characteristic of deabsorption or drying of the sample is taking place, and after that the curve is similar to that of the curve first. Clear?
Yes, sir.
Yes. Now see the curve third. What this curve third represents? You will see that that is a horizontal line, and that is a slanting downward portion in the curve, right? So this shows a single stage decomposition. You will see that this is a single stage decomposition curve. It means some material, a single material has been decomposed in this region, right? So we have discussed previously that this is a horizontal portion, this is slanting downward portion. After it's become stable. So this is an ideal curve for a TGA which show a single stage decomposition. Now, when you see the curve 4, you will see that there are multiple steps are there. And the curve is similar to that of 3, but there are multiple stages. So it will show a multi-stage decomposition. Multi-stage decomposition, and where stable intermediates of the stable intermediates are formed at this particular step, right? And it provide information on the temperature limit of stability of reactant and intermediate products, and also stoichiometry. So this is a single stage decomposition curve. This is a multi-stage decomposition curve, curve
So
4.
can you please give an example of this type of change?
For example, okay, lateral the slide, I have an example, right? For multi-stage decomposition,
Okay,
right?
sir.
For example, if you are taking a calcium carbonate, right? So at one temperature first, it will what? There will be evolution of water molecules, and at second, at nearly more than 150 degrees centigrade, there will be evaporation of carbon dioxide. So it will be a multi-stage, it will be a two-stage decomposition process will take place, right?
Okay, sir.
Okay. Now coming to curve fifth. Curve fifth, that is similar to that of curve four, right? You will see that curve fifth is similar to that of curve four, but the steps are not clear. You will see that the steps are not clear. So you can say that it is also a multi-stage decomposition curve, but it is not stable. There is no stable product that is formed here, right? There is no stable product that is formed here because all the steps, that these steps are not clear. So you so it can be inferred that the there is some error with the running of the sample, and this is due to the high heating rate, right, or very low heating rate. So you have to optimize the heating rate to get a curve like curve 4. So curve fifth is also a multi-stage decomposition, but here you can see that no stable intermediates are being formed. So the heating rate must be considered for if you are obtaining this type of curve. It should be adjusted to get a curve like curve 4. Clear? Clear to all of you?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes. So if it is been asked in the exam ki show a curve for multi-stage decomposition where no stable intermediates are formed, then you will draw a curve like this, right? On the y-axis it should be mass, on the x-axis it should be temperature, and your curve is this. So a curve for multi-stage decomposition where the intermediates are being formed, you will draw a curve 4. Single stage decomposition, curve 3. 1 and 2 we have already seen. Now, what about curve 6? What about curve 6? Yes, you will see that with increase in temperature, there is increase in the mass of the system. Yes. What does it mean? Yes. Anyone?
Sir,
Sir,
it
it's
means
reacting with
Sir,
atmosphere.
it is
the sample
absorbing
reacts with the.
moisture.
Yeah, the sample is somehow gaining mass, right, with increase in temperature. It means oxidation of the material is taking place. तो ऑक्सीडेशन कैसे होगा, क्यों हो रहा है? Because the sample is not put in an environment controlled condition, right? Somehow it is reacting with the environment, so there is a linear increase in the mass of the temperature with increase in temperature. So if you are obtaining a curve like this, you have to stop the analysis, and again you have to optimize the parameter, and again you have to read the sample, right? Now if you are obtaining a curve like 7, the last curve, what does it mean?
Sir,
That
Sir,
that at with
sir,
it
it
is
first
having
gains mass, then decomposes again.
yeah. First it is oxidizing, then it is decomposing. So this is not also an ideal curve. Again, you have to resolve for the sample. It is reacting with atmosphere, and with increase in temperature, it is decomposing, right? So this is lot of occurred in TGA, but sometimes you can see such type of curve. So you can, from this curve you can see that the general you'll see that the ideal curves are curve 3 and 4, from which you can analyze your samples. Clear to all of you the different curve for
Sir,
TGA?
sir, is curve
Yes.
7 valid or invalid?
देखो यहाँ वैलिड और इनवैलिड की हम बात नहीं करते हैं. कभी कभी क्या होता है, ये सब एरर्स होते हैं, आपको अपडेट करते हैं, लेकिन ये ऐसे कर्व्स जो होते हैं ये आइडियल नहीं है आपके टीजीए एनालिसिस के लिए. फॉर एग्जांपल देयर इज इंक्रीज इन द मास आफ्टर डिकम्पोजिंग, फ्रॉम दैट यू कैन नॉट इन्फेयर एनीथिंग, ओनली यू कैन से दैट इंक्रीज इन मास. जब इंक्रीज इन मास होगा तो फिर आपके लिए वो टीजीए एनालिसिस आप उसका कर नहीं सकते हो कुछ भी, है ना? So it is important from the curve what the results you are getting. भाई वॉल्यूमेट्रिक एनालिसिस आपने किया और टाइट्रेशन में इंडिकेटर ने कलर चेंज नहीं किया है ना, तो उससे तो आपके लिए कुछ नहीं निकला, है ना?
Yes, sir.
फॉर एग्जांपल फिर आपने टीजी एनालिसिस की, तो टीजी एनालिसिस फॉर एग्जांपल यू आर ऑप्टेलिक कर्व लाइक फर्स्ट स्ट्रेट लाइन, only you can say that material is stable, right?
Yes, sir.
So for any analysis there should be some interpretation must be there, or interpretation of the curve must be there. So if you are saying the curve third, you can see that, oh, it is a single stage decomposition, then from the curve what is liberating out, right? This is a multi-stage decomposition. Then you can realize, oh, what is the product that has been formed, what is the volatile product that has been evolved in the system with increase in the temperature, right? So clear, all the curves are clear in TGA.
Yes, sir. Yes, sir.
एग्जाम में आता है कि draw a curve where there is increase in the mass of the system with increase in temperature or where the oxidation of the material is taking place, then you have to draw curve 6, right? और clearly आप draw करोगे और axis भी clearly बताओगे आप कि y axis पे आपका क्या है और x axis पे क्या है, और एक सिंगल कर्व उसको clearly draw करोगे, right? So what are the different factors that affect a TGA curve, right? So there are two Bell factor, that is the instrument factor, and a second one भी, one is the instrument factor, दूसरा क्या होगा जो TGA curve को affect करेगा आपके?
Experimental.
क्या चीज?
Experimental factors.
That is the nature of the sample. दो ही चीज कर सकते हैं, या तो इंस्ट्रूमेंट में आपको कोई दिक्कत हो तो वो टीजीए कर्व को अफेक्ट कर सकते हैं, या फिर आपका सैंपल में कोई दिक्कत हो, या फिर इट डिपेंड ऑन द सैंपल. सो इंस्ट्रूमेंटल फैक्टर इज द फर्नेस हीटिंग रेट, recording or chart speed, furnace atmosphere, geometry of sample holder, location of sensor, and sensitivity of the recording mechanism. So these are the factors that affect the TGA curves. And the sample sample factor that affect the TGA curve is the amount of the sample, the solubility of the evolved gas in the sample, particle size, heat of the reaction, sample packing, and nature of the sample. These are the factors that affect the TGA curve. Now the question is, how the furnace heating rate will affect the TGA? Yes, anyone?
So if the heating rate is high,
If the
curve will be very condensed.
or very low, then you will obtain a curve like this. You will curve a curve like fifth, right?
Yes, sir.
Recording and charting speed, if you are giving a high temperature, and for example I am saying that 30 or degree centigrade per minute, it will also affect. Furnace atmosphere, if it is not kept in an environment control system, then it will affect. Now geometry of sample holder and location of samples, for example only geometry of the sample holder, how it will affect. Yes, what should be the geometry of the sample holder in which you are keeping the sample?
Sir, maybe surface area affected.
Surface area of the sample. Yes, so
सर ताकि पूरे सैंपल की एक
Uniform
समान
heating.
तरीके से हीटिंग हो सके,
हाँ.
यूनिफॉर्म हीटिंग.
तो यस, यूनिफॉर्म हीटिंग हो सकता है, उसके लिए सैंपल होल्डर कैसा होना चाहिए?
So cube.
हाँ, क्यूब्स. अच्छा, और
Spherical.
so next class I will ask what should be the geometry of the sample holder for optimum TGA analysis. ये आप सर्च करना, right?
Yes, sir.
हाँ. Now, when you are talking about the sample characteristics, that amount of the sample will affect, solubility of the evolved gas in the sample will affect the TGA property, particle size, heat of the reaction, sample packing, and nature of the sample will affect the TGA analysis. Now coming to the applications of, we need to prepare the, applications of TGA. So this TGA analysis can be used for both qualitative and quantitative analysis. And for qualitative analysis, it is mainly used to study the stability of the substance at elevated temperature, identification of the substance and their purity determination, and it can be used for decomposition mechanism of polymer and inorganic salts and etc. So this TGA can be used for both qualitative analysis. Qualitative means? Yes, anyone?
Which deals
Qualitative.
with
Its physical properties.
Depends on the substance type.
which deals with their chemical properties.
Qualitative, it means you can from viewing the sample or from the general analysis, you get about the qualitative representation of the sample. For example, by seeing the curve, you can say about the stability of the material. Okay, you can say that it is stable up to that temperature, right? Then you can say what is the identification of the substance and their purity determination and decomposition mechanism of the polymer. So these are a qualitative analysis that you can analyze by seeing a TGA curve. Now, in quantitative analysis, it aims to establish how much of a substance is present in the sample, right? So from the TGA curve, you can do the quantitative analysis by establishing how much of a substance is present in the sample. So an example has been discussed here. For example, let's us illustrate that TGA method to estimate Ca2 plus and barium 2 plus ions in a mixture. Suppose you have provided with two monohydride oxalate of calcium and barium, and you have to estimate how much of the calcium and barium ion is present in the mixture. So you will first take the sample. For example, you have taken a 0.6025 gram of the sample and is subjected to heat at the rate of 5 degrees centigrade per minute. So after 320 degrees centigrade, at 320 to 400 degrees centigrade, you will see that there is a slanting downward portion, and there is a mass loss from 0.6025 to 0.5713 grams, right? And this mass loss in the temperature range correspond to the obtained combined loss of water from monohydrate oxalates of calcium and barium. So at this temperature, there is a water loss from this salt, right? After that, with further increase in the temperature, just a minute, I will take a call. Yes. So yeah, in quantitative analysis, it can be used to estimate calcium ion and barium. It can be used to estimate how much of substance is present in the sample. And here is an example and the calculation that is shown on screen. That is a very simple calculation. So you will see that at 320 to 400 degrees, there is a first wet loss, and this is due to the liberation of the water molecules. And at 580 to 620 degrees centigrade, there is liberation of carbon monoxide from the system. That is the second mass loss. यस, आप लोग को दिख रही है कैलकुलेशन, दिख रही है स्क्रीन पे?
Yes.
Yes, sir. Yes, sir.
Yes. So this is a simple calculation how you can calculate the calcium ion and barium ion from a given water sample. Given sample. Now, this TGA can also be used for finding the amount of filler in a polymeric sample. Suppose you have been provided with a sample, for example, polyester resin. Now it is reinforced with calcium carbonate filler material. These filler materials are being added in the polymers to provide strength to the polymer. And I'm saying that, okay, you have to calculate how much of the calcium carbonate is present in this polyester region. Now for this, what you will do, you will go for a TG analysis, right? So just a minute. So you will see that when you are doing a TG analysis, yes. Constantly. Yeah. So uh, yes, where were we? क्या बात कर रहे थे हम? Yes.
So
Are
we
you
were
there?
discussing about
Polymer
TGA.
TG
Yeah, yeah,
analysis.
yeah.
Sir, TGA analysis.
TG analysis of polyester region that is reinforced with calcium carbonate. So on the screen you will see that this is a typical curve for calcium carbonate filler with polyester region. So you will see that there are two portions, that is loss of weight in the region first and this is loss of weight in the region second, right? So this loss of weight in the region first is due to the decomposition of the polyester and removal of the volatile. And the loss of weight in region second is due to the liberation of carbon dioxide. So this is a type of, you can say that this is a type of multi-stage decomposition, right? Someone was asking ना कि curve दिखाने के लिए बोला था, आप देखो this is a typical curve for calcium carbonate filled with polyester region. So you will see that there are two regions where there is a change in the mass of the system, and from this you can calculate the percentage of CaCO3 uh, by using the formula, that is percentage CO2 into molecular weight of calcium carbonate divided by the molecular weight of CO2. So by using this, you can calculate the percentage of calcium carbonate present in the given sample. So TGA can be used for both qualitative and quantitative analysis. For qualitative analysis, it can be used to estimate the stability of the material and identification of the substances and decomposition mechanism of the polymers, and in quantitative analysis it can be used to establish how much of a substance is present in the sample, and it can also be used to find the amount of filler in a polymeric sample. Yes, clear to all of you?
Yes, sir.
Any doubt you want to ask? Yes. Anything you want to ask? No questions? कोई क्वेश्चन नहीं है? सबको समझ में आ गया?
हाँ सर।
Yes, sir.
So in the next class we will discuss about differential thermal analysis, that is DTA, right? Second method of thermal analysis that you have to say, that is differential thermal analysis, that we will discuss in the next class, right? Yes, anything more you want to ask?
सर एग्जाम्स के लिए हमें ये टॉपिक कहाँ से पढ़ना चाहिए?
ये टॉपिक कहाँ से पढ़ना चाहिए? बुक जो है इसकी एक अलग ही इसकी अलग सी बुक है. दैट बुक आई विल प्रोवाइड द नेम ऑफ द बुक, बट डोंट गो थ्रू वो स्पेशली इसी के लिए बुक. आई विल प्रोवाइड द नोट्स फॉर दैट, राइट? नोट्स और स्लाइड को आप देखो, राइट? आपका काम हो जाएगा इसके इस यूनिट के लिए.
ओके, थैंक यू सर.
Okay, sir. Thank you.
एनीथिंग मोर?
सर प्रैक्टिकल्स में थर्मल एनालिसिस करेंगे हम?
प्रैक्टिकल में थर्मल एनालिसिस नहीं है आपके. आप में वॉल्यूमेट्रिक एनालिसिस है और स्पेक्ट्रोस्कोपी ही है. बट थर्मल एनालिसिस में आपको इंस्ट्रूमेंटेशन जितने हैं वो आपको पूरे याद होने पड़ेंगे और ड्रॉ करने हैं आपको, है ना? That PPT this PPT I will load in the Google Classroom. That's not a problem. Apart from that, I will also upload some lecture notes on the volumetric analysis and thermal method of analysis also. That will not a problem. ठीक है, आप एक बार उनको go through होना, एक बार पूरे volumetric analysis आपको लगता है ये point सर मुझे समझ नहीं आया, that I will upload a lecture note on that. And that we will discuss in some classes. अगर कभी हमारी rest classes free होती है तो हम उसमें उस points को discuss भी कर लेंगे. You just note down that points, right? आप एक काम कर सकते हो कि note down कर सकते हो और अपने CR या किसी को बोल के ना आप पूरे पॉइंट्स को, सर ये पॉइंट्स थे हमें डिस्कशन, तो हम एक पूरे क्लास में उन पॉइंट्स को हम रख सकते हैं और डिस्कस कर सकते हैं. ठीक है?
Yes, sir.
So any more questions? Saurabh is there?
Yes, sir.
Saurabh, attendance मुझे भेज देना. 51 students are present, right? Including me. So I think 49 students are present here, right?
ओके सर, मैं भेज दूंगा.
तो 49 के भेजना, जो भी 49 के तुम भेज लेना. ठीक है? Clear?
Yes, sir. Yes.
So let's end for the today's class. Okay. Good day to all of you.
Yes. Okay, sir.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.